Okay, here we are on lesson 2.4, the multi-step inequalities. So what are you going to learn today? Today you're going to learn to solve multi-step inequalities. We'll use some of the multi-step inequalities to solve real-life problems. So when we're doing this, when we're solving these inequalities, the key to remember is that you want to simplify each side of the inequality if necessary. Then use the inverse operations to isolate the variable. Be sure to reverse the inequality symbol when multiplying or dividing by a negative number. So we're going to basically be doing everything that we've learned so far or reviewed so far. So let's take a look. In example 1 from the textbook, to solve each inequality and then graph each inequality. You can see that in A, it's a two-step equation. First, y is being divided by -6 and added by 7. All of that is less than 9. So to begin solving, we subtract 7 from both sides. We finish that up by multiplying both sides by a -6 and then not forgetting to reverse the symbol. So, right, this is really important at this step if you're multiplying or dividing by a negative number. And then we get y is greater than -12 and we graph it, which is an open circle. So in part B, we will first add 4 to both sides, then come back and divide by 2. Notice that we did not need to reverse the symbol because we were not dividing by a negative number. All right, so extra practice. We get to try these. So we are going to first, let's see. Add 2 to both sides. So 3x is less than 12. Finally, we'll undo this multiplication with division so that x is less than 4. Mark the number line until you have a few numbers in front of and behind the number. Since the symbol is less than, it's an open circle at 4, and it will shade in all the numbers to the left, all the numbers that are less than 4. And to check your work, you might want to say like, okay, 2 is one of my solutions because it's graphed. Is 2 less than 4? And that's another way, making sure that you graphed it correctly. All right, continuing on with problem 3. Notice that we skipped 2. We are on page 46. Hopefully you figured that out already. So the first thing we want to do is come in here, hold on, and subtract 2 from both sides. Okay? So I'll kind of move over to the left. We'll have b divided by -3 on the left, less than or equal to 3 minus 2 is 1. Okay? How do we undo dividing by a -3? We multiply both sides by -3. Since we are multiplying by a negative, we must also reverse the symbol. So b becomes greater than or equal to, because the -3's cancel out, -3. Okay? And so to graph it, we will get some numbers going here. All right, and it is going to be a closed circle at -3. Since it is greater than or equal to, it can be part of the solution, and all the numbers that would be greater than or equal to -3. All right, in example 2 with variables on both sides. Again, we're just going to use the same steps that we've always used in solving equations, meaning first simplify both sides, or simplify the equations or inequality on either side. Then use inverse operations and the properties of addition, subtraction, multiplication, and division to isolate the variable. All right, so let's go ahead and try some. So this is problem number 6. So I kind of jumped ahead here. All right, first step. I'll go ahead. I'm going to try to get the variable to the left. So I'll move this constant to the right. So I'll subtract 5 on both sides. So negative 2n is greater than 8 minus 5 is 3. Bring down the rest. I will add then 4n to both sides. And notice we're not being asked to graph this one. So negative 2n plus 4n. All right, it's probably a good thing because now we're going to divide both sides by 2. We're dividing by a positive number, so there's no need to reverse the symbol. And n would be greater than 3 over 2 or 1.5, however you want to show that. But it's okay to leave it improper as long as it's simplified. All right? And also I would accept a decimal answer as long as it's not a repeating decimal. If you get a repeating decimal, there's no way for us to notate that, so that's where you always want to keep it in a fraction form. So, and let's see what else we're going to do. All right, sometimes when we're solving these, you're going to obtain an equivalent inequality that is true, such as negative 5 is less than 0, right? It's true, negative 5 is less than 0. So the solutions of the inequalities are all real numbers, okay? If you obtain an equivalent inequality that is false, such as 3 is less than or equal to negative 2, the inequality has no solution. So these are just showing you the graphs of all real numbers, right? The entire number line. We could substitute in any value for the variable, and it would be true. And then for no real solutions, there's nothing that we could graph if we had to graph it. So I don't believe we're going to be asked to graph some of these. All right, number 7 and number 9. Notice that I skipped number 8. All right, so we have variables on both sides. So let's see, let's add 18 to both sides. So 6h is less than 6h plus 19. This is number 7. Okay. Then we will subtract. Oh, that's an h and I made it an n. 6h from both sides. Okay, that cancels, so we get 0 is less than 19. Since 0 is less than 19, right, this is true. So, all real numbers is our answer. Okay. Looking at number 9, we want to combine the like terms of 7j and negative 4j first. So simplify if you can. All right, we'll subtract the 6 on both sides. So 3j is less than negative 8 plus 3j, so we'll subtract 3j on both sides, and that cancels it out both times, so 0 is less than negative 8. Is 0 less than negative 8? Not true. So here's where we say no solution. Okay? So be very careful with that. Remember how tricky it was when we were doing the equations. So make sure you understand that if the inequality is true, it's all real numbers, and if the inequality is not true, it is no solution. All right, let's try number 10. Number 10 has some parentheses, so we want to simplify first. So we're going to distribute. Remember, you want to distribute to both terms inside the parentheses. So 12 times 1/4 is the same as dividing 12 by 4, so 3w. And 12 times 3 is 36. That's going to be less than or equal to, and then we'll distribute the 3w minus 12. So let's subtract 3w, right? That cancels out. So is 36 less than or equal to negative 12? Not true, so no solution. Okay? All right, and this is actually from your textbook, so we're not doing number 11 and 12. You can find maybe some extra room over 11 and 12 if you want to copy this down. We're going to need a mean score of at least 90 to advance to the next round of the touch screen trivia game. The scores in the 5th game will allow you to advance. So your scores for game 1, game 2, game 3, and game 4 are in the box to the right. So a couple things that we need to keep in mind, right? We have to make sure that we understand that when it asks for a mean score, they're asking for an average, and to calculate an average, you add up all the scores and then divide by the number of scores there are, okay? And we need at least 90. So it can be equal to 90, but it can also be greater than 90. So to do this, we have 4 games there. So let's say x is equal to our 5th score. Okay, so we can add up the scores they gave that we had, 95 plus 91 plus 77 plus 89 plus x. All of that divided by 5 has to be greater than or equal to 90. So on the left, we'll combine the like terms, so we can basically add all of these numbers together. And if we add them up, I got 352. So 352 plus x divided by 5 is greater than or equal to 90. So to solve for x, we first have to get rid of the 5. So we first have to undo dividing by 5, and we're dividing by a positive number, so we do not need to reverse the symbol. So then we get this expression, 352 plus x is greater than or equal to, and when you take 90 times, make sure you understand that's a times 5, I got 450. And then we're subtracting 352 from both sides so that x will be greater than or equal to 98. So we need to score at least 98 on the 5th game in order to advance. Okay? And at the very end, make sure it makes sense. You might want to check your work. You can add that 98 in with the other 4 scores. Divide by 5 is that at least 90, and it will be. All right, that concludes notes on lesson 2.4.